Going to keep solving equations today, but these equations are going to have a slight variation to them. All right, think about when we graphed our trig functions. Now, if I just said graph sine x, we knew that graph just went from 0 to 2 pi, right? High point was 1, low point was -1. You don't necessarily have to draw this. This is just my little explanation. Okay, so if I just asked for sine of x, we had a graph like that. So if I want to know when sine x was equal to 1/2 between 0 and 2 pi, we can see clearly it happened 2 times on there. But what if I said you had the sine of 2 of x? Do you remember from graphing, what did that 2 change? Yeah, it was like our stretching and shrinking. We called it our period. Period is how long it took to repeat. And so it was always 2 pi divided by the number in front of x. So this graph has a period of 2, of pi. So what happens is when we graphed it, it had already done a complete cycle by the time you got to pi. And so if I asked every time it equaled 1/2 between 0 and 2 pi, is it just going to be 2 times anymore? No, because by the time I get all the way to 2 pi, my graph has done 2 complete cycles. And so that one actually ends up with 4 answers. If I said sine of 3x, how many cycles would I get between 0 and 2 pi? I would get 3 complete cycles. So how many answers would I actually get? 6. So when we change that period, it impacts our answers and the number of answers you get. So there are really 2 ways to do these problems. I'm going to teach it one way, but if you get confused or you don't like it, tell me and I'll show you another way. I just think it gets confusing if I start saying you can do this or this or this and I show too many things at once. So I'm going to try to pick the method that works the same no matter what. But if that doesn't make sense to you or you see it another way, I can show you another option. All right, so let's look at this equation. If it's an x over 2, what is the period of that? Period is normal period 2 pi divided by the number in front of x, which would be 1/2, so that would be 4 pi. So that means if I'm only giving answers between 0 and 2 pi, I may or may not have all my answers, right? Because I only have half the graph by then. When we solve it, we're going to start off solving like normal. So just like you would have done before, get the cosine by itself. Okay, so we add our radical 2 over, divide by 2. Quadrants and reference angles. When is cosine positive? Which quadrants? Reference angle. When is cosine radical 2 over 2? 45 degrees. We are in radians, so we'll say pi over 4. Okay. This is where it's slightly different. Not really, but my angle is x over 2. So when I set this up, x over 2 can equal pi over 4 in quadrant 1 is pi over 4. In quadrant 4, 7 pi. So nothing has changed so far. It's just like the other problems. If I'm solving for x, what do I have to do now? So to get x by itself, I'm now going to multiply everything by 2. So I get pi over 2 and 7 pi over 2. So to answer my questions, part A. A only wanted the answers between 0 and 2 pi. Pi over 2 is there. 7 pi over 2, that's 3.5 pi. So that's not in between 0 and 2 pi. So part A, I just get one answer. Part B, when I say all solutions, so that's when you're used to adding the 360k, right? Except for in radians, so it'd be 2 pi. However, we did 2 pi because that was the period. That was how long it took for the graph to repeat. What was the period on this one?
4
pi. So my all possible solutions will be each of these plus 4 pi k, where k is an integer. Any questions on that? So then, sine of 3x equals negative 1. So my sine is already by itself. I don't have to do anything there. Let's talk about period for a moment. What is the period for this? Normal period is always 2 pi divided by the number in front of x. A lot of times I just look at this and I see, oh, there's a 3 here. That means I'm going to have 3 complete cycles of my graph. So I'm going to have triple my solutions. And I'll show you what I mean by that in a second. But I usually write that note to myself so I know when I solve this, it's going to give me the first round of solutions for the first period. But I know if I'm going all the way to 2 pi, I'm going to have 3 periods in here to think about. All right. So now we always just say our angle, which is 3x, equals, when is sine negative 1? Sine of 90 is 1, so for the negative 1 it would be 270, right? We're in radians, so that is 3 pi over 2. Or if you're thinking about the unit circle, sine is your y. Y is negative 1 right there, 3 pi over 2. Okay. This is my first answer. But remember, I'm going to get 3 complete cycles. So if I have triple solutions, I got the first answer, but how many do I need? 3. Okay. This is where there's different ways on how to do it, but this is what I like to do. I know I need 2 more answers. What you can do, if we do it before we divide by 3, is we can get all of the others just by adding our normal 2 pi to them. Okay, you can use a calculator, just don't put in pi. So 3 halves plus 2. So 3 over 2 plus 4 over 2 would be 7 pi over 2. Plus another 2 pi, so plus another 4 over 2 would be 11 pi over 2. So now, to get x by itself, what do we have to do? Divide by 3. So I'm dividing every one of these by 3. Or think of it as multiplying them by a third. So we get pi over 2, 7 pi over 6, and 11 pi over 6. You can use a calculator. If any of them get ugly, just don't plug in pi. Just do the fractions. You notice I wanted everything between 0 and 2 pi. 2 pi is 12 over 6, so we stopped right before that. So this is my answer. This gave me everything on that interval. B, if I say all solutions, all I really need is the first one, my pi over 2. Because the others were the extra answers I got, right? If I start with my first one, what's the period of this graph? So we would just have to add 2 pi over 3k. Now, if you put all of them plus 2 pi over 3, are you wrong? No, it's just redundant. If you do 1/2 plus 2/3, you get 7/6. Plus 2/3 again gives you 11/6. So there's different ways of writing it. We're just trying to go with the most concise. What questions do you guys have there? Let's practice a couple more like this. When I look at this one, the 2x tells me double solutions, but what's my angle on the other one? X. We need our angles to be the same. Okay, so what thoughts do you have? Don't we have identities for these formulas? Look at your cosine 2x. Pull out your flip chart, double angles. Cosine 2x, we have 3 options. My other function is sine. So what option do you think would be the nicest? Okay, and again, the reason I did that was because my angles weren't the same. But once I did, now they're both x's, so now we can solve. Do I even have to worry about the period being weird on this one anymore? No. So this is just solving like normal. So quadratic, bring everything over. Okay, what would I do? All right, what multiplies to a -2 and adds to a +1? Divide our 2 back. I get sine to be -1 and +1/2. Again, at this point, my angle is x, so I don't have to do anything weird. I'm just answering this question. When is sine -1? We were in 270 degrees, which is, okay, sine equal 1/2. In which quadrants is sine positive? Reference angle. When is sine 1/2? Which is pi/6. So pi/6 in quadrant 1 is pi/6. In quadrant 2, pi/6. I only asked for the answers from 0 to 2 pi, so I don't have to do plus 2 pi k. So identities might still come into play here, and then we may not have to worry about anything different. Do we have a secant 2 theta formula? No, so we probably just need to solve this. What would we do with the negative? Okay. Personally, I don't like thinking about secant, cosecant, or cotangent. I always flip them. That means cosine is 1 over that, or negative radical 2 over 2. This is a 2 theta, which tells me I am going to have double the solutions, because it will have 2 full cycles by the time I get to 360 degrees. Its period is just pi 1/8. Quadrants, when is cosine negative? reference angle. When is cosine radical 2 over 2? So my angle, 2 theta, can equal, in quadrant 2, 45 degrees would be 135. In quadrant 3, 2. Okay, but that's not going to get me all of my answers. Double solutions, so we need 2 more answers. Right, to get the next one, all you have to do is add the normal period before any changes. So we're going to add 360 degrees to each of these. So 135 plus 360, 495. 225 plus 360, 585. That's what 2 theta equals. So how do I get theta? Divide each of these by 2. I get 67.5 degrees, 112.5 degrees, 47.5 degrees, 292.5 degrees. And notice this is right up until the end. We'll move to 360. Are you guys understanding the strategy I'm using here? So if this were a 4 theta, then I would have had 4 times the solutions, right? So I would have had to keep adding 360 until I had 8 total and then divide all those by 4. Okay, let's do probably one more and then I think I'm going to stop for today. I have multiple functions, but they're both a 2x, so we can leave it. We don't have to use a formula. But the 2x does tell me what will happen. We'll have double solutions. Okay. So I have 2 sine squared of 2x minus the sine of 2x minus 1. Second side. Multiply to negative 2 and add to negative 1. Have to flip it so we get negative 2 and positive 1. Divide our 2 back. So sine of 2x can equal 1 or negative 1/2. So my answers, 2x equals, when is sine 1? Okay, negative 1/2. Sine is negative in quadrants 3 and 4. Reference angle, when is sine 1/2? So 30 degrees in quadrant 3, 210 in quadrant 4, 330, 360 minus 30. Okay, I have 3 answers, but at the beginning I said double solutions, so how many should I get? 6. So for each of these numbers, what do I have to do? Add 360. So we get 450. 570. So part A is wanting all my answers between 0 and 360. We're almost there. To find x, we now divide each of these by 2. So we get 45. Okay with that? We did have a part B on this one, all possible solutions. So on that, you really just need your initial 3. So the first 3 plus our period. So our period on this one, normal period is 2 pi. If we're in degrees, that's 360 degrees. Divided by the number in front of x, so that's 180. So we would have 45 degrees plus 180 degrees. Okay. 5 plus 180 degrees. Okay. 65 plus 180. Okay. Do I need the other 3 then? No. So if you do 45 plus 180, you get the 225. 105 plus 180 gives me the 285. Does that mean I would count it wrong if you wrote it on your paper? No, it's not wrong. We just don't need to list it. It's already included